So there are a lot of advantages for additive. I've shown you some of those. I'll give you a couple more examples here, and then we'll open it up for some questions. Obviously, being able to run small lot sizes. We don't need special purpose tooling. Give me the CAD, the 3D file, I'll set it up and print it. We're good to go. The ability to customize your parts. So very low, small lot sizes, being able to do customization. A lot of the early work was in dental, medical, implants, particularly over in Europe. Invisalign braces now, for instance, is all custom braces that are 3D printed for you. So there's whole businesses now out there based on this. Quick turnaround time. I think this is really where you have a big opportunity from an MRO perspective is you're not necessarily going to make it lighter or less expensive, but you're going to make it quicker. Because you're not having to wait for the tooling, you're not having to wait for this, you're not having to wait for that. It is going to change the dynamics from a send me the file, print it, and I'm good to go. And we've seen anywhere from a 5x, 10x significant speed up there in terms of that. You've got a lot of flexibility as you're designing new parts, lightweighting components, we talked about that. Those sort of things. The buy to fly ratio, so how much material you're buying versus and machining away versus how much is actually on the aircraft itself. So here was one example of the lead time improvement. NASA is investing a lot in this. Essentially, this particular part, this baffle, welded and assembled together, 9 to 10 months. With this process, 9 days. So we've gone from 9 months to 9 days because of this. So think what that allows you to do in terms of prototyping, getting your designs ready, getting parts out there, et cetera, et cetera. I mean, this can go in all sorts of different ways. Significant time and cost savings. So plus, it's better because we're not having to rely on all these individual welds, so it's a more structurally sound part. So it's even performing better, and you're able to get it out there quicker. GE, if anybody's been following, they are the poster child in terms of additive manufacturing. The LEAP engines, these nozzles. The previous design was 18 different components. Now they're printing it as one single part. 25% lighter, performs better, et cetera. Now the challenge, though, they need 100,000 of these in like the next 5 years. There aren't enough machines out there right now to print that many, let alone the supply chain, let alone the powder, let alone the training on the operators, let alone everything else. So they are making significant investments trying to build up that supply chain. Well, that's on the sort of the forward. What about when the repair and maintenance and those sort of side? That's all going to be, this is going to follow that as well. They actually, though, were able to just get the, 2 weeks ago now, the GE has the first FAA approved 3D printed part to fly on an aircraft. First one ever. So the FAA has finally cleared it. They're working on about another dozen components for the LEAP engine. They've got $135 billion in inventory or orders waiting to be made for this technology. So this is a huge, huge game changer for them. I think they're planning to invest about $3.5 billion in the next 5 years to make this a reality. When was the last time anybody was talking about investing those kind of dollars in a manufacturing technology and its implications? So that's pretty exciting stuff. So exciting opportunities there. So coming back to the end, repair, refurbishment. I already mentioned the repair opportunities there with those couple of things, and you're already seeing this in the military as well, the logistics side of things. And so the Mobile Parts Hospital, if you're not familiar with this, you can Google and check that out. They sort of sort of rethinking logistics. You're out in Iraq or a war zone, wherever the case may be. Something breaks, something doesn't work. You're not going to wait around for them to ship that part and get it out there. You want the ability to be able to fix it, repair it, get up as quickly as you can. So basically, they figured out here's an 8-foot standard 8x8 by 20 shipping container, completely outfitted with machines, software, computers, satellite link-ups, compressed air, the ability to level it so that they can get those parts repaired and refurbished or made new as quickly as possible, get them deployed, and keep the officers up and running. Over 6 years, they made 100,000 parts, and the next version they're talking about is going to have some of this 3D metal printing capability. So in that case, it becomes an asset that helps you get to the end quicker in terms of that. It's not redefining the logistics or anything of it, but it's going to become another tool in the arsenal that's going to help you get net-shaped parts and move very quickly. And then the Rapid Equipping Force. Is this some of the LMI work that you guys had done there? Looking at what sort of technology do we need in these expeditionary labs. So again, the shipping container idea, if we're going to drop that down what 3D printers and other tools do we want to be able to have there? And I think one of the key things here is they recognize who are the personnel that are going to be running this. Okay? And so, yeah, we need a combat soldier, so we got somebody who's out there. What are the needs? What are the repairs? What are the things that aren't working well? You got a couple of engineers. I guess you can guess who the engineers are in the picture, right? And then, we can guess who the special forces operator is as well, right? So you've got the deep field expertise. You got the the customer interface, and then you got the guys in the back that are doing this. And it's so the team plus the tech that makes this happen, right? And so these are now getting out there and getting fielded and seeing some good results for them as well. So the opportunity, of course, the Navy, not to be left out, has said, Admiral Dunaway, I think initially 2017, I think he's given him a few extra years, basically said we're going to have 3D printers on aircraft carriers to be able to just, instead of carrying around all these parts, we got powder, we got a machine, we're going to print them and go. Not all as easy as a MakerBot per se, but you need a special tool. You do have a floating factory on these, parts where you got mills, lathes, et cetera. Again, you're going to add a 3D printer. There's going to be another tool in the arsenal there to be able to help that and be able to print the fleet. And of course, I mentioned the CT scanner. Challenges right now with what are the IP and copyright issues here? Because I can scan any of these parts. Now I got a point cloud. I can print that. Who's going to stop it? There's no way the file doesn't contain any of that information. So what does that mean? Your now MakerBot sells a digitizer for $800. I can scan a part and print it. So now are we going to design parts that can't be reverse engineered? What does that look like? Well, what are the CAD tools to do that? How are you going to do that? Or how do we use that? So, a big question. We're doing some work with, logistics right now and repair. If you don't have the technical data package and you need to repair that part, where are you going to get that information? We'll go to this. And then if we avoid that, what does that mean or not? So, again, you're sort of redefining all of this. And I just had to put this up here because I love the title of that article. It'll be awesome if we don't screw it up, written by Michael Weinberg, a lawyer. One of many that's checking this out now in terms of what's going on with intellectual property in 3D printing. So